Good morning, pre-calculus students. I apologize for getting this out a little bit late. I know most of you have already gone through this section. However, I just wanted to put up a video covering a couple of things just to make sure that we're all on the same page. So in 11.4, we're talking about conic translations and rotations. These are transformations which we've done to every type of graph that we've looked at so far. Okay? With conics, up until this point, we've always centered our conic at the origin 0, 0. Now we're going to center it at some other point. That other point will be hk, where h is our x value and k is our y value. That hk is going to be the center for ellipses and a hyperbola, and the vertex for parabola. Right here we have a demonstration showing how the center of an ellipse can change. Right here it's centered at 0, 0. Right here it would be centered at 2, -1. We can see how the center was shifted and we got our h and k. Super easy of h and k. All right? So if you look at the table on page 720 in your book right here, it's going to show you how the h and k transformations are applied to all of the conic equations that we've looked at so far. All right? Notice that the h is always paired with the x, the k is always paired with the y. All right? Another thing you should really pay attention to is for the ellipse and ellipse and the hyperbola, the focus and vertices are also shifted based on our h and k value. This makes sense. They're moved from the origin as well. Alrighty? Notice the asymptotes are also shifted in a hyperbola. Okay? So whenever we're trying to solve the equation for one of these, we're trying to find values of h, a, k, and b for our ellipse and hyperbola, and typically h, k, and p for our parabola. Now, there's a very easy way to differentiate conics based on the equation that you're given. Okay? When we're talking about conics so far, we've only dealt with second degree conics. That means they're only going to have a highest power of 2. Second degree equations can have the form ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. Your a, b, c, d, e, and f are all going to be constants. If it's a 1, it's not going to show up. If the variable doesn't show up, then your constant is a 0. All right? Now, we can use the discriminant to figure out what type of conic it is. We've seen discriminant before with quadratic equations where we use it to see if we can get a real answer. Okay? So the discriminant is just going to be the b squared minus 4ac term. You're only going to be worried about the first 3 terms of the equation. Alrighty? If the discriminant is greater than 0, it's going to be a hyperbola. If the discriminant is equal to 0, it will be a parabola. And if the discriminant is less than 0, it will be an ellipse. Okay? Finally, some of the questions in your homework are going to ask you to graph these equations on your calculator. In order to graph it on your calculator, you're going to need to solve it for y before you input it into your calculator. If you're sketching it, it's often easier to have it in standard form, but to put it into your calculator, it will need to be solved for y. Right, I've taken the liberty of doing a couple problems for you guys, just so you can get a feel of it. The first about 16 problems are the most difficult in this section, in my opinion. That's where you're finding the equation of conics using the table on page 720 and the information we've learned in chapter 11 so far. Number 6, we're finding a hyperbola. We're given the center of -5, 1, the vertex of -3, 1, and that it's passing through the points -1, 1 minus 4, the square root of 3. So, based on what we talked about earlier, the center is going to give us our h and k values. Our center, the h is going to be -5, the k is going to be 1. Furthermore, we know the center is on the line y is equal to k because we can see the center and the vertex both have this 1 term. The y is the same. Therefore, we're going to be using the equation of the form x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Alrighty? Now, to find our a, we use the fact that the vertice is shifted by the h value here. So we know that h minus a is k is one of the vertices, and h plus a, k is one of the vertices. When we do that, we solve for a and get a value of 2. Now, at this point, all we need is b. So we're going to use our x and our y from our passing through point, plug them into our equation like so. Please make sure you have your x, your h, your y, your k, and your a, otherwise it won't work out. So then we simplify our equation. -1 minus -5 would be 4, and then 1 minus 1 minus 4 to the square root of 3 will just give us -4 to the square root of 3. We continue simplifying and we find b squared is equal to 16. We could go ahead and solve for b here, but if you look in our equation, all we need is b squared. So in our final step of this, we're going to plug our h, k, a, and b into our equation and get this form of the hyperbola. Number 12, we're dealing with the parabola, so we only need to solve for 4p. Okay? So we're given the vertex is 1, -3. The vertex of a parabola is the hk. Remember, the center of a hyperbola and ellipses is hk. The vertex of the parabola is hk. So we usually get our h and our k values. It's telling us it has an axis y equals -3. -3 is our k, so it has the axis y is equal to k. So this will be of the form, the quantity y minus k squared is equal to 4p times the quantity x minus h. Now we're just going to plug our x and our y from our point that we're given, the passing through, very much in the same way that we did for number 6. And we get -4 minus -3 squared is equal to 4p -1 minus 1. We just simplify this and we get 4p is equal to -1/2. Then we plug our we plug our h, k, and p in, and we're done with the problem. The next 3 problems, I have examples of using the discriminant. Remember, when we're talking about the discriminant, we're talking about second-degree equations of this form. The discriminant is going to be our b squared minus 4ac. So we're going to look at our given equation, find our a, b, and c terms, do this simple equation, and see what happens. In this first one, we have x squared minus 2xy plus 3y squared. Our a will be 1, our b will be -2, and our c will be 3. We plug them into b squared minus 4ac and simplify, and we get -8. That is less than 0, so number 17 will be an ellipse. Number 39. Oh, whoa, what happened? What is our x squared and our xy? They're not there, therefore a and b are 0. Our c is still there, and that's 3. We simplify and we get 0, so this will be a parabola. In number 50, we have 11x squared minus 24xy plus 4y squared. A is 11, b is -24, c is 4. Plug them in, we get a value much greater than 0, so this is a hyperbola. Alrighty, please let me know if you have further questions on this section. I know it was a lot of material, but I have utter faith in you guys. I'll see you in the next one.